Let's consider a series circuit with a voltage source. So we have three resistances connected with a source. Let's say this one is E volts, this is R1, R2, R3, and the series current is I. So from Ohm's law we can say that the voltage drop here, if we call it V1, and this one V2, this one V3, from Ohm's law we know that V1 is IR1, V2 is IR2, and V3 is IR3. And from Kirchhoff's voltage law we know that sum of voltage drops will be equal to sum of rises. So this one is rise here if we go counterclockwise direction, in the counterclockwise direction. So E will be equal to V1 plus V2 plus V3, which is IR1 plus IR2 plus IR3. So this can be written IR1 plus R2 plus R3. So that's E. Now what we can see here, the combination of these three resistances, because they are connected in series, is coming as a sum. So this is RS. So when there are more than two or more than two resistances are connected in series, the combination equivalent value is RS is the sum of the resistances. So sum of R's, basically in this case R1 plus R2 plus R3, if there were more, so that would be up to Rn, like that. So we can say, yeah, Rn. So whatever number of resistors are connected in series. Similarly, this is the equivalent value of series resistance. Similarly, if we will now consider if resistances are connected in parallel. So let's say we have a current source and three resistances connected here, like that. This is R1, R2, R3, and this is I, and the voltage drop here is V. This will be the same drop here, same drop here, and same drop here, because these are connected in parallel. So if current here is I1, this is I2, this is I3. So from Kirchhoff's current law we can say I1 plus I2 plus I3. I is equal to, because this is entering current and these three are leaving currents. So if the voltage drop from Ohm's law, we can say that I1 will be V over R1, because the voltage drop, the parallel voltage drop is V. Similarly, this will be V over R2 plus this will be V over R3. And if we want to find an equivalent value, equivalent resistance of these three parallel resistance, so if we want to replace it with one resistance, let's call that RP, then this is I and the voltage here is V. So I will be V over RP, the total I. So we can say on the left hand side is V over RP, and this is V over R1 plus V over R2 plus V over R3. So if we get rid of V, then we get, so basically cancelling V from both sides, we get like that. So this is the parallel combination, this RP, of course, because one resistance is replacing all three resistances, and that is the formula for parallel resistance is given like this. So this is the equivalent parallel resistance inversely added, and the equivalent is also inverse, like that. So this is again for as many parallel resistances as connected, so it goes up to n, 3, 5, 10, however many. So that's there. Now if there are only two parallel resistances, what we get is, let's say we have two resistances R1 and R2, and we want to find the parallel combination. We sometimes show it like this, the resistance seen. So that will be again the same formula, 1 over R1 plus 1 over R2, just two resistances. We often encounter, we often have to do find the equivalent resistance of two parallel resistances, so we will just focus on this formula. It's the same formula, but what happens here is R1 R2, R1 plus R2, that's 1 over Rp. So Rp becomes the equivalent of two parallel resistances becomes like this. So this is something we try to remember, because we often have to find the equivalent of two parallel equivalent resistance of two parallel resistance, and this is the formula we directly use for that case. So this is for, of course, just two parallel resistances. So yeah.